While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it. and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigan have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry. They say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigan's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Okay, here you are, in the middle of the ocean. It's endless, but you can't see it, because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we've found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just one day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP-76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP-76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the Sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the Sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The Earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updating. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
Is it possible to put out the sun? For example, what would happen if we poured all of the Earth's oceans on it? Or even more water? Well, let's find out. The universe is a place full of mysteries. Since ancient times, scientists have been arguing about how space works. But none of us has ever doubted the existence of one thing: the sun. The center of our solar system. It's big, bright, and immortal? Nah, not really. Actually, the sun is just an ordinary star. It consists of 75% hydrogen, a little helium, and a pinch of other heavy elements. Gravity holds it all together. But in around 5 billion years, the life cycle of the sun will come to an end. The hydrogen inside it will run out. Our star will begin to grow gradually, and you can't even imagine just how big it will become. And then it will start eating all the nearby planets. That's when we'll regret being so close to it. After eating us all, the star will remain a red giant for another billion years or so. And then, sooner or later, it will begin to shrink and fade, turning into a white dwarf. In the end, nothing will remain of it but a bright and colorful planetary nebula. But don't get scared. Right now, the sun is in the middle of its life cycle. It was born about 4.5 billion years ago, and about the same amount of time remains. Fortunately, we were born during the star's best and most stable period. In other words, there's no reason to worry. So let's find one. How about speeding up the sun's life cycle with the help of water? We'll try to collect all the water on Earth and pour it onto the sun. First, we'll need a bucket. No, not this one. We'll need a really, really big bucket. the one that can contain around 326 million cubic miles of water. It will be equal in size to the distance from Washington to Chicago. Or if we can only find ordinary buckets, there should be around 70 quintillion of them. This is a number with 18 zeros. Okay, imagine that we magically got that many buckets. It's time to put out the sun. We splash the star with all this water and nothing? Seriously? Oh, just look at this. The sun has probably felt sorry for us and produced one little solar flare. It turns out that all water on Earth is actually just a pathetic drop for the sun. People often underestimate how much bigger the sun really is than our planet. In reality, it can fit more than 1,003,000 Earths. So yes, the sun won't go out or even get colder. It won't even notice that we've done something. But let's not give up. We really want the sun to go out for some reason. What happens if we pour just enough water on it? And how much is this enough? Remember our quintillions of buckets? Well, we actually need about 370 octillions of them. This number has 27 zeros. It's hard to even imagine, so let's just say that it's a lot of water. Now, let's splash it all over the sun again. Wow, just look at the steam! But the sun hasn't gone out again. On the contrary, it said thank you and suddenly became much bigger and brighter. What's happening? You see, the sun isn't actually a campfire. Inside bonfires, candle flames, there's a chemical combustion. When we pour water on the fire, the water absorbs the heat of the flame and cools it to such an extent that it can no longer maintain the burning reaction. It also blocks the fire's access to oxygen. Water basically stops the chemical process. But the burning of the sun isn't the same reaction. Even though we say it burns, it's not entirely true. What happens there is called nuclear fusion. It's one of the most violent and craziest reactions in the universe. There are many layers of hydrogen going deep into the sun. If you take 4 hydrogen atoms and ram them together, you're left with an atom of helium. When we talk about the sun, the process is a little more complicated. When the star tries to carry out that fusion, positive protons repel each other. It takes a lot of force and energy to somehow squeeze them together. Fortunately, there's a magical force in space. It's gravity. The sun takes up 99.8% of all the mass of the solar system. Pretty heavy, right? And all this mass is what holds the sun together with the help of an incredible gravitational force. So, gravity takes quadrillions of these little hydrogen atoms and pushes them together every second of every day. And when they collide, they release some energy. So, unlike fire, the sun doesn't need oxygen to live. It needs hydrogen. And we all know that water is H2O. It consists of hydrogen and oxygen. So this is literally fuel for the sun. It's like trying to put out a fire with gasoline. More importantly, the extra mass added by water will make the sun heavier. Now, gravity says, thank you for your help. And then it starts to collide protons with each other even faster. And thanks to this, the synthesis speeds up. Great, we've made the sun incredibly strong, and now it has eaten us, along with other nearby planets. And if we keep adding water, the sun will sooner or later collapse in on itself. It will blow off its outer layers and become a black hole. Awesome! Now it will pull inside absolutely everything around. Good job, guys. Let's press rewind because clearly our water experiment was a mistake. One small solar flare sounds much better. Alright, we're back to our usual calm sun. But it seems like there's something that we've forgotten. Well, apparently, water was critically important for life on Earth. Who would have thought? Now there's a huge amount of unmoving fish and other marine creatures lying around where the oceans used to be. Poor things. As for deep sea creatures, they simply didn't withstand such a sharp change in pressure. Algae and corals have also dried up. Wait a minute, weren't they responsible for producing 50 to 80% of the world's oxygen? Oops, it's time to put on some oxygen masks. And how are things on dry land? I mean, now everything is just land. But you get the point. Wow, this whole place is lit, and I mean it literally. If there are no oceans, then there are no clouds or rain. Now there are forest fires everywhere. Poor animals have to escape and leave their homes. Oh my. And it's not like they'll be able to find a new home, because all plants, of course, will dry up quickly. There will be literally no place for living left on the planet. So now Earth looks like a giant desert. Great! But people have been living in deserts for thousands of years, right? Maybe they'll know what to do. They won't. After all, people in the desert also need to drink. So now there's total chaos everywhere, and survivors fight for the last drops of water. If there are any survivors at all. In fact, no matter how much they fight for resources, their fate is sealed. The ocean absorbs a huge amount of CO2 and the heat coming from the sun. They also distribute this heat throughout the planet, making it pleasant to live on. But once they're gone, the temperatures will quickly jump to 250 degrees Fahrenheit and above. But even if we forget about the high temperatures, now we have no clouds, and they helped us too, by not letting through solar radiation. So we're also under the direct impact of the sun's rays. Our last hope is icebergs. Now that everything is terribly hot, they've melted. And maybe they'll be the last hope for humanity. But that cool solar flare was definitely worth it. Silly humans.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turned to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip. 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's gonna be as chaotic as can be. In stellar mechanics, it's called the 3-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who will have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. we divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X-solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Shoals. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Shoals bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our Sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns.
Now, did you know that our sun is actually green? Okay, I'm kidding. But in reality, it's all colors you can imagine at the same time. Wait, what? I know it sounds like a joke, but I'm being serious, can't you tell? In fact, our sun contains absolutely all the waves of the light spectrum. It's simultaneously red, blue, green, yellow, you name it. Where do you think rainbows come from? When sunlight gets reflected off water droplets in the air, it splits into a bunch of colored waves that we can see individually. And when they're all together, we see a white ray of light. Our eyes are unable to perceive the concept of all colors at the same time, so their combination seems white to us. Wait, you might say, why white? Isn't the sun yellow? Yep, it's yellow too, but please don't stare at the sun just to make sure. It appears white when we see it from the International Space Station. This is the sun's real color as our eyes perceive it. The sun gets a yellowish hue when its rays get scattered in Earth's atmosphere. Our atmosphere doesn't let the blue rays of the spectrum pass very well, but the red ones? Hey, sure, why not? By the way, that's why the sky seems blue to us. The atmosphere scatters the blue color all over the place. During sunrise and sunset, short blue waves get reflected, but the long red ones reach us perfectly. That's why we see sunsets as pink, orange, or red. But what would happen if the sun had a different color? To answer this question, let's quickly repeat what we've learned. 1. The sun has the whole color spectrum in it. 2. Our atmosphere is like blue rays? Nope. Red rays? Anytime. So you probably already guessed what would happen if the sun was, let's say, red. The whole world would look like it does during sunsets. Not bad, huh? We wouldn't even have to wait for the evening to admire the scarlet sky. Orange water and a bright red moon. Yeah, it would be darker than what we're used to, but still not bad. Oh, by the way, one day, the sun will actually turn red. When its life comes to an end, it will expand and gradually turn into a red giant before finally burning out. But it's not going to be so much fun for us. So let's hope we won't be around to see that moment. I know I won't. Hey, I've got a party to go to. Okay, now, what if the sun was green? Well, the truth is, the sun is green. So here's your dialogue.
Wait, are you kidding me? Didn't you just say that it's white?
Ooh, good job on that, by the way. Well, not exactly, bud. The sun just looks white, but technically, it has a temperature of around 10,000 degrees Fahrenheit, and the pink wavelength of the sun's spectrum corresponds to the green-blue hue. But to make sure that the sun is green, we need to drown out the rest of the visible spectrum. Then our atmosphere will let through a pure green color. And what'll happen then? Well, everything will be green, and everything will also be a bit darker. Well, face it, it's not easy being green. Okay, moving on. Now let's paint the sun blue. Blue stars actually do exist. They're called blue giants. Fortunately, our sun is not one of them. Why fortunately? Well, because if it was a blue giant, it would be a young, beautiful, unimaginably large, and very, very hot star. See, our red is hot, blue is cold logic doesn't apply to stars. The hottest stars are white and blue, and the coldest are yellow and red. Yeah, our sun is actually very cold compared to other stars. Now, take the average temperature in your city, but multiply it by hundreds of thousands. Yeah, we're struggling with global warming here, but global burning? No thanks, blue giants. Anyway, let's imagine that the sun turned blue. How would we see the world? Surprisingly, nothing would change. Remember how I said that the atmosphere scatters blue light? That's why, in this case, everything would remain almost the same. Maybe the sky would get bluer, but we wouldn't see much difference. And finally, the darkest, pun intended, option. What if our sun turned black? Stock up on lamps and candles because there is no more light. People use electricity all over the world 24/7. We also can't see the moon anymore. After all, we can observe it these days only because the sun's rays get reflected off of it. Now, the only thing we still have to illuminate our nights are stars, but they don't help us much. Good thing this scenario is totally unrealistic and there are no black stars, right? Well, yeah, there are no black stars, and still our sun will eventually become completely black one day. And I don't mean a black hole. I'm talking about black dwarfs here. You've probably heard of white dwarfs, maybe even seven dwarfs. When a star like our sun is about to finish its life, it expands and turns into a red giant. And then, gradually losing its upper layers, it turns into white dwarfs. Since they no longer produce fuel, they slowly cool down. All that remains is a small core, living out its life and burning bright. And when the star cools down completely, it turns into a black dwarf. But you've probably never heard of them. Why? Because, surprise, surprise, they don't exist. And no, I was not lying. The thing is, a star needs about 1 quadrillion years to turn into a black dwarf. And our universe is still a baby. It's only about 14 billion years old. So no star has reached this stage yet. Even the most ancient of them still emit a little light. That's why black stars are just a theory. And it's unlikely that we'll ever see such a star at all. But remember the famous saying, the stars that we see at night are already ghosts because their light has reached us only now. Well, that's a myth. They're all still alive. Why am I telling you all this? Well, let's imagine that our sun turned into a black dwarf. The entire solar system would immediately get plunged into absolute darkness. It would also be terribly cold. The moon would leave its orbit and crash into Earth. Wait, no. Let's overlook this moment and assume we're still alive. Fortunately, we wouldn't freeze instantly, as you might think. Earth's core has its own temperature, more than 9,000 degrees. But the temperatures on the surface of the planet would still immediately drop to 32 degrees Fahrenheit. The core would gradually cool down. Every 2 months, its temperature would drop by 2 times. In just 2 months, Earth's surface temperature would be minus 190 degrees, and in a year, it would reach minus 450 degrees. Most plants would disappear pretty quickly, not because of the cold, but because of the lack of photosynthesis. Others would live a little longer thanks to the oxygen still remaining in the atmosphere. And, oddly enough, trees would survive for a very long time. They have a slow metabolism and get sugar from the ground. The upper layer of the oceans would freeze very quickly. Fortunately, this thick crust of ice would insulate deep waters, so the entire ocean wouldn't freeze for some time. Marine creatures would be doing pretty well. They existed long before us and are already used to crazy temperature changes, the lack of oxygen and food, huge pressures, and other joys of deep-sea life. And what about us humans? Well, first of all, we'd start getting sick. Without vitamin D, people would face a huge number of different health problems. Also, our bodies need sunlight to produce melatonin. This melatonin helps us understand when we should go to bed and wake up. If people didn't have this hormone, their bodies would get very confused and wouldn't understand whether they needed to sleep or not. That would mean insomnia for many people. But we would still be able to survive. We'd have 2 options: to build giant submarines and go down into the depths of the ocean closer to Earth's core, or stay on the surface, living our lives in some location where we'd have sources of geothermal energy. In Iceland, for example. We could also settle near volcanoes. Their heat would be enough to warm us for a long time. Our vision would adapt to the dark, but at some point it would reach its maximum. So we'd need to get used to living in complete darkness. But who knows? Maybe we would adapt to this life too. So, which option would you prefer? Living at the bottom of the ocean in a submarine or on the surface near volcanoes?
Arcturus, a huge red star. It's just bursting from inside out. The red sea of plasma on its surface rages and pulsates. The star burns anything that comes close to it. And now, flop! Arcturus is gone. But at the same moment, it reappears at the center of our solar system, replacing the sun. What we see in the sky isn't a small yellow dot anymore, but a giant red ball. It's 25 times wider and 30% heavier than the sun. Even though Arcturus is a little cooler, it's still a total nightmare for Earth. The distance from our planet to the star is now 25 times less. All the water in the oceans and rivers begins to evaporate. What used to be rainforests are quickly turning into a lifeless desert. But sunsets and sunrises now look amazing. Imagine yourself on the roof of the Empire State Building, watching the sunrise. First, you see the light over the horizon. It almost blinds you because Arcturus is 110 times brighter than the sun. Then, the star gradually climbs over the surface. The thick dot on the horizon gets wider and wider. It continues to grow until the red star is everything you can see. Arcturus is now so close that you can even see storms of hot plasma on its surface. There are periodic outbursts and mass ejections. Huge amounts of matter are ejected from the surface of the star at speeds of up to 1,200 miles per second. The matter takes the form of a loop attached to the star at both ends. And you have to wear a super advanced spacesuit to be able to observe such a sunrise. Life on Earth ceased to exist long ago under these conditions, and it's going to get worse over time because every 8 days, Arcturus's brilliance increases, and soon our planet will become more like Venus. It's so close to the sun that the high temperature makes any life there impossible. Okay, let's let our planet cool down a bit and put Proxima Centauri in the center of our solar system. It's not a red giant, but a red dwarf. This star is almost 7 times smaller than the sun and almost 9 times lighter. Now our oceans and rivers are not evaporating, but freezing over. Forests and jungles are covered with snow. In about a week, there won't be a single place on Earth where the temperature is above freezing. Even plants that are used to the cold will cease to exist. They mostly feed on the sun's energy. Now, they begin to starve. But there will still be water deep beneath the ice layer. It'll be heated by the hot core of our planet. Microorganisms will still be able to survive. It's much darker on Earth too. It's like an endless twilight here. Oh, and we can barely see the moon. The thing is, it doesn't produce its own light, but reflects it from the bright sun. With Proxima Centauri instead, the moon will lose its brightness.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
But an even bigger problem would be with our orbit. The sun has a certain gravitational force, and it keeps us just in the sweet habitable zone, where we're not too hot and not too cold. Proxima Centauri's gravity is much weaker, and Earth is slowly drifting away from the star. We now run the risk of encountering asteroids flying through space, or even other planets. But the worst-case scenario is if Proxima Centauri simply can't hold our planet, and we fly away into dark space. Then, you can forget about any forms of life here. Now, let's put Sirius at the center of our solar system. It's the brightest star in our night sky. It's only 70% bigger than the sun, but almost twice as hot. So its glow is not only bright, it's sizzling. And its light is not yellow, but somewhere between blue and white. You couldn't go out in the city without sunglasses, or Sirius glasses. Still, you wouldn't want to walk the streets, where the asphalt is boiling anyway. You could literally fry eggs on the curb. Of course, by this time, all life on Earth has long since disappeared. But it's not just because of the temperature. Sirius emits enormous amounts of radiation. Our atmosphere serves as a shield against the sun. But in the case of Sirius, that shield wouldn't be enough. Now, why don't we take a more bizarre approach and make ourselves a double star system? These are 2 stars that revolve around a common center. And there's our Earth, safe and sound. It's all about the size and brightness of the stars. These 2 aren't too big, and they give off as much light as our sun. All that matters to us is that our planet is in the safe zone of the double star system. At sunrise, you first see one star appear from below the horizon, and then, a couple of minutes later, the other. The only problem is that this beauty may soon explode with enormous force. In binary systems, one star is always heavier than its companion. Sooner or later, it starts pulling matter away from the smaller star. Gradually, the bigger star just eats its neighbor. Then the big brother can reach a critical mass and explode. This explosion would be about as strong as a supernova. It would destroy our entire solar system. The light from this explosion would be visible for hundreds of light years away. And after that, there would be a huge nebula in the place of our star system. It's stardust and particles that are left from our world. Going to the realm of the crazy now, a black hole. Yes, there's one at the center of our solar system now. We know black holes are scary, mysterious objects that pull in everything in their path. But even around a black hole, there is a habitable zone. You just have to be far enough away so that it doesn't drag you down into its black abyss. Mercury and Venus would be too close to the black hole, so most likely they'd be torn apart and then head for the event horizon. This is the last stop before hitting the singularity, the heart of the black hole. There are only two problems: light and time. A black hole pulls light in instead of emitting it, so the Earth will quickly become dark and cold. And time goes slower around heavy objects. Near a black hole, 1 second can be equal to weeks or even months away in outer space. We won't feel this difference, but the entire universe around us will develop faster relative to us. Any object can become a black hole if it's compressed to a certain size. For example, the Sun can become one if it's shrunk to a width of 3.7 miles. And even the Earth, if you squeeze it to a width of 0.7 inches, it becomes a black hole. Oh, now there's some little rock lurking in the center of our solar system. It's a neutron star. It's about 18 miles wide. Some meteorites are much bigger than that, but it has a mass comparable to the Sun. So its gravitational force is about the same, and our planet's orbit is intact. But the problem is that neutron stars emit next to no visible light, so it's now permanent night on Earth. Still, it gets very hot here. When a neutron star is born, it can be several times hotter than the Sun at first, but it quickly cools down to the temperature we're used to. So there's a chance that all life on Earth hasn't yet been scorched. Another problem is that these little guys are rapidly spinning and can become pulsars. It's kind of like a powerful spotlight on two sides of a spinning star. Neutron stars also eject radiation at tremendous speeds. These rays will make our planet literally sterile. No life form would be able to exist under these conditions. And now, it's time for the biggest star ever known, Stephenson 218. This red giant is 2,150 times larger than the Sun. And if we place it at the center of our solar system, its edge will lie on Saturn's orbit. So Mercury, Venus, Earth, Mars, and Jupiter are already swallowed by the huge star. Saturn, Uranus, and Neptune are roasting like chestnuts on a fire and will soon evaporate. In fact, this could happen to our Sun as well. The older it gets, the redder and bigger it becomes. It'll eventually run out of its fuel, hydrogen, and the Sun will start to burn heavier elements in its core. This will cause it to expand. Then we'll see more beautiful sunsets and sunrises, but the temperature will become too high. In theory, the Sun will get so big that it'll swallow the Earth, and then it'll explode in a supernova, leaving nothing of our entire solar system behind. Shiny. It's becoming colder by the minute. The temperature drops below zero very quickly, and although there's no snow, the cold is becoming unbearable. Hoarfrost appears on the ground, the grass, and the trees, and ice forms on bodies of water at an incredible rate. Shivering people all over the planet raise their eyes to the sky, and their jaws drop in disbelief. The Sun has become twice as small as it used to be. It now looks like a distant speck, and it won't be able to heat the Earth any longer. But the worst thing is, there's a huge blazing rock coming right at the horrified spectators from the sky, and the impact with that thing will undoubtedly do a lot of damage. Okay, let's go back to our objective reality. The Earth is exactly in the sweet spot of our solar system. It's neither too close nor too far from the Sun, making the temperature on our planet not just tolerable, but rather pleasant. Scientists often call Venus, the second planet from the Sun, our Earth's evil twin, because it's so hot and inhospitable that no life is possible on it. Of course, there are thick clouds in its atmosphere that rain acid, and the greenhouse gases raise the temperature on the surface to unbearable values. But even if Venus didn't have those, nothing would still be able to live there because of the proximity to the sun. If there was any liquid water, it would evaporate too quickly, leaving life no chance to develop. On the other hand, Mars, going next in line after Earth, is a bit too far away from the sun, which makes it cold and lonely. The temperature on its surface is below freezing, and it never warms up enough for water to stay liquid for long. That's not to mention the lack of atmosphere on the red planet, the element that provides the Earth with breathable air. So, if our planet shifted closer to or farther away from the sun, its temperature would either rise or fall respectively. A few hundred miles wouldn't make much difference. The circling of Earth around the sun is uneven anyway, and we constantly get nearer to our star or fly a bit away from it. The distance that would matter is measured in millions of miles. And yeah, just like I showed you at the beginning of this video, we'd see the sun a lot smaller than we do now if we went that far. The temperatures might not fall at the exact moment of the shift, as there would still be some warmth left. But in the following winter, our planet would probably stay cold forever. The oceans would be covered with ice, and the overall sea level would drop. And ultimately, the ice would reflect more of the sun's heat back into the atmosphere and space, not allowing the surface of our planet to get the necessary warmth. And more ice means less water vapor in the atmosphere. Water vapor captures heat too, creating clouds. So the colder it is, the less rain. The cold and the lack of rain would not let any plants survive for long. So the areas of icy and barren landscape would grow fast, leaving only the areas along the banks of rivers intact for a while. After some time, the rivers would stop running too, either frozen or dried out because of losing their sources, lakes and seas, which would, of course, freeze as well. Any life dwelling near them would disappear. Plants first, and with them, everything else, since plants produce both food and breathable air. And with that, the Earth would become a frozen wasteland. As for the giant blazing rock I mentioned, it was an asteroid coming from outer space because of the shift of our planet's orbit. Jupiter, the largest planet in our solar system, acts as a natural shield for us against space rocks. It has a huge mass, and most asteroids flinging from outer space get caught in its gravity and fall on its surface. There's no life possible on Jupiter, and its surface is gaseous, so asteroids tend to disappear in it without a trace. Still, some manage to get past Jupiter, where Mars comes into play. It also contributes to our defense by holding the asteroid belt between itself and Jupiter in place. The two planets' combined mass creates a gravitational field that doesn't allow the asteroids from the belt to fly in random directions, hitting everything in their path. If there was no Mars between us and the belt, we'd be used to meteor showers almost more than actual rains. Say the Earth has replaced Mars in its orbit, and now we're hundreds of millions of miles farther away from the Sun. The mass of the Earth is more or less similar to that of Mars, so the asteroid belt is still in its place. The temperatures will still fall though, and life will soon go extinct. But if Mars stayed where it is, and the Earth just shifted away, it would be a recipe for disaster. There's no chance the planets would orbit the Sun at the same rate because their mass is not equal. At some point, they would collide with each other. Taking their speed into account, they'd both crack and shatter, perhaps creating another asteroid belt in our solar system. It would be no more hopeful for us if the Earth decided to jump closer to the Sun. Apart from the star seeming more like a giant, pitiless, blazing ball in the sky, its heat would melt the glaciers on our planet, making sea levels rise abruptly. The water would flood major parts of the continents, and more surfaces of the planet would be covered with water, which means more heat absorption. That would bring about a further rise in the temperature. Also, those large bodies of water would evaporate like crazy, releasing tons of water vapor and carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that absorbs heat, and so does water vapor. Together, they would trap more and more of the sun's warmth, creating thick, roiling clouds in the sky, almost like on Venus, but without the acid. And that thick blanket of clouds would also contribute to heating the surface of our planet. In the end, the entire Earth would heat up so much that life on its surface would become unbearable for most. Only the sturdiest of creatures would be able to survive temperatures so high. Those that dwell in our deserts, for example. Despite the rainfall, which wouldn't cease as in the cold scenario, plants would still have difficulty adapting to the new and hot environments. The ones in the cooler regions of the planet would be the first to wilt and go. But then, plants from the moderate and finally tropical climes would also give up. And, yet again, the Earth would turn into a barren ball of rock, only this time an overheated one rather than frozen. Our planet's distance from the Sun, its tilt, its speed of rotation around its own axis, its orbit around the Sun, and even the presence of the Moon in its skies, all of that is crucial for life on Earth to exist. For instance, if the planet wasn't tilted relative to the Sun, it would be unbearably hot on the equator and impossibly cold at the poles. The seasons would also stop changing, dividing the Earth into strips of endless summer and winter. Our planet is heated up evenly from all sides with the current tilt and rotation, like you would roast a barbecue. It turns to the Sun with one side to warm it up, while the other cools down during the night. Were there no change of night and day, we'd probably only live in some areas of our planet where constant, never-ending twilight would be. Just imagine our life without those beautiful sunrises and sunsets. Maybe we'll just let it stay as it is, okay?
A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new object gets so strong that nothing can escape it, not even light. That's how a black hole is born. The black holes closest to our planet are called Gaia BH1 and Gaia BH2. They were discovered thanks to the data collected by the European Space Agency's Gaia spacecraft, hence their names. Both are about 9 to 10 times more massive than our Sun and are located a mere 1,560 and 3,800 light-years away, respectively. In cosmic terms, they're situated in Earth's backyard. And there's something seriously wrong about these black holes. So, should you pack your emergency bag? Let's find out. The remarkably close black holes are likely to represent a previously unknown category of these mysterious objects. What sets them apart from others is that they're orbited by stars at much greater distances than scientists have observed previously in other black hole companion star pairings. Normal black hole companion star systems are known as X-ray binaries. They are usually bright in radio and high-energy X-ray emissions. They swallow matter and emit powerful bursts of energy, which makes them pretty easy to spot. Now, why did it take astronomers so long to spot these massive black holes residing right inside our home Milky Way galaxy? All because they're almost invisible. In the past, astronomers spotted black holes by looking for the remnants of their meals. The thing is that when a star or even a cloud of interstellar gas is pulled into a black hole, it leaves behind a trail of electromagnetic radiation. And scientists use it to detect the presence of a black hole. But unlike other holes discovered before, Gaia BH1 and BH2 are pitch black. They don't seem to be snacking on anything at the moment. This makes them inactive, or dormant. So astronomers had to use another method. they tracked the movement of two companion stars orbiting these cosmic monsters. The stars, similar to our Sun, wobbled a bit while traveling through space. To researchers, it was a sign that something with a lot of gravity, like another star, was tugging on them. Interestingly, when they examined the area with the help of telescopes, they didn't find anything emitting radiation, so the whole situation only made sense if there was a black hole involved in the process. Luckily, Gaia is perfect for spotting invisible black holes. Thanks to its state-of-the-art equipment, it can accurately measure the motion and position of billions of stars. No other instrument is capable of such precision. Gaia's observations were backed up by the data received later by other observatories. For instance, NASA's Chandra X-ray Observatory, as well as the South African Meerkat Radio Telescope, revealed no visible light coming from Gaia BH2. So even though they detected nothing, it was still valuable information. It told astronomers a lot about the environment around the black hole. A lot of particles are coming towards it from the companion star in the form of stellar wind. But the researchers didn't spot any radio light. It means that the black hole doesn't have much of an appetite, and not many particles cross its event horizon, or the point of no return. Unfortunately, it's still unclear why that is. Anyway, should we be worried about those mysterious black holes lurking in the darkness of space so close to our planet? I've got some good news. There's absolutely no reason to worry. First of all, these black holes are sleeping at the moment, and it doesn't look like they're going to wake up anytime soon. Secondly, they're still too far away to affect our life, and it's not like black holes know how to travel.
So, do you know why the ocean is salty? We didn't know the reason until 1979. The whole planet is covered with ocean, and we had no idea where all that salt comes from. We initially thought rivers were to blame because they can carry deposits and chemicals to the still waters. It wasn't until the late 1970s, when scientists stumbled upon so-called black smokers, that we realized they were the cause of the salty waters. They are, in fact, geothermal vents located along the mid-ocean ridge. They were generated from sediments of iron sulfide from deep within the Earth's core. Okay, remember dinosaurs? I don't. I wasn't around then. But they disappeared a long time ago. Yet how that happened was still up for debate within the scientific community for a very long time. Up until 1991, no less, the year the Chicxulub crater was discovered. That's a big hole located underneath the Yucatan Peninsula in Mexico. Many claim it was formed when a giant asteroid crashed on Earth. The oldest material ever found on our planet turns out to be older than our entire solar system. The Murchison meteorite plopped into Australia back in September 1969. But we made this staggering discovery after a newer analysis of its debris was done only in 2020. Did you know that there is a coral skyscraper hidden underneath the ocean, and we had no idea? Only in 2020, a team of Australian scientists stumbled upon it when mapping the northern Great Barrier Reef. It's 1,640 feet tall, which, if you think about it, makes it taller than the Empire State Building, and no elevators. Do you know how mountains appeared? We didn't know that until 1966. And that also concerns earthquakes and volcanoes. Just think about it. We sent men into space before we even understood how and why the Earth under our feet started moving now and then. Only in 1966, a scientist named J. Tuzo Wilson published a piece in the journal Nature in which he explained that continents and oceans are constantly moving. He also wrote about tectonic activity, meaning things like earthquakes and how mountains rose from the Earth's surface. Until 2021, we hadn't mapped out a full human genome sequence. The concept of DNA was first presented by a Swiss scientist back in 1869, but specialists remained partially in the dark as to DNA's physical structure until Rosalind Franklin and Raymond Gosling took pictures of it and found it looked like two twisting strands. Ever wonder what the largest living organism in the world was? For a long time, scientists did too, because they only stumbled upon it in 2000. It's a fungus that lives 3 feet underground, but is estimated to spread across 2,200 acres. Located in the Malheur National Forest in the Blue Mountains of eastern Oregon, it's named the honey mushroom. Until 2002, we didn't know what was at the center of our galaxy, the Milky Way. We knew we were rotating around something, but it took us until the 21st century to figure out it was a supermassive black hole, with a mass 4 million times bigger than our Sun, located in a region of the Milky Way called Sagittarius A star. The discovery took place after we came up with the infrared smoke alarm. I can hardly imagine having to travel long distances without wheeled luggage, but these didn't pop up until 1970. If you think about it, the astronauts who went to the moon actually had to carry their baggage in the spaceship physically. The application for the U.S. patent for the wheeled luggage was granted back in 1972, but to be fair, those first ones weren't exceptionally reliable. They had problems like wobbling and tipping because the large suitcases were mounted on narrow-wheeled bottoms. If you look at pictures of 1940s film stars, you'll see that their hair was nice and slicked back. Did you know that based on recent discoveries, even ancient Egyptians used some hair-molding substance? What they used, though, wasn't hair gel, if that's what you're thinking, because we only came up with this invention in the 1960s. What people used for hairstyling back then in the 1940s was called Brill cream, which had more of a waxy consistency and was invented in 1929. Hair gel, as we know it today, came a bit later and was invented by a man named Louis Montoya. It soon became trendy because it wasn't as greasy as previous products. Speaking of bathrooms, and I am about to, back in ancient Roman times, they used some sort of, wiping devices, but they were sticks with a sponge on top. Individually perfumed sheets of paper that had the same purpose appear to have been documented in China back in 589 CE. However, in the US, medicated paper for the water closet was marketed in the late 1850s, but the soft and comfortable variant of toilet paper was commercialized only in the 1930s, with the added bonus of being completely splinter-free. And I think we can all appreciate that. This one may not seem so recent, but hear me out. Modern research revealed that Saturn's rings are less than 100 million years old or so. That may seem like a lot, but if you think that the solar system formed about 4.5 billion years ago, it does shift your perception a bit, right? There are species of sharks on Earth that have been around in our waters 4 times longer than Saturn's rings. We figured this out using recent data regarding the mass of Saturn's rings and their ratio of dust and ice. With many of us resorting to e-commerce more and more these days, it's challenging to look at the traditional supermarket as some revolutionary invention. But we didn't have these for as long as you'd think either. Do you know how the first supermarket appeared? Well, back in 1916, a shop owner named Clarence Saunders needed a solution to make his job less labor-intensive, since shopping around then meant he had to pick out all the products from the aisles and even deliver them to customers. So he thought about a new shop layout with a turnstile entry. People had to browse the shop in a single direction. He also made sure they were passing by all the available products. Customers could pick their items themselves and had to take their produce home. The shop owner could lower his prices with added efficiency, since he needed fewer people to run the business. Did you know there's still a state in the US where wearing a seatbelt isn't mandatory? Historically, using a seatbelt was voluntary, but people being the way they were, safety needed some enforcement. The state of New York was the first one to pass a law that enforced seatbelt wearing while driving, but only on December 1st, 1984. Still, to this day in New Hampshire, there are no laws on the matter. The modern can opener, the one with the spinning wheel, was first introduced to the market in 1870. Now, that may not be remarkable, but it seems odd when you think canned foods were already available for some decades. Before this invention, we were told to literally cut around the top of the can near the outer edge with a chisel and hammer. You got a meal and an excellent workout all in one. Did you know that standardized time became enforceable by law only in 1880? The current system that we use now, GMT, for Greenwich Mean Time, became a common practice in most countries even later, somewhere by the end of the 1920s. Now, we used to estimate what time it was by looking at the sun's position in the sky. We then evolved to using clocks, but they were still dependent on the sun's position in a particular town or village. That meant time could differ slightly between two neighboring communities. And it wasn't that big of a deal for us until the invention of trains. As we started to travel faster and on longer distances, we needed to figure out a way to know when a train would leave and reach a certain destination, which could be helpful for all travelers in various locations. And frankly, it was about time. We're traveling 1,000 light-years from our planet to an unfamiliar system. Here, there are two bright stars orbiting close to each other. But there is one small but very massive thing here as well – a black hole. These objects are mysterious and dangerous. They're capable of swallowing our entire world in 1 second without even noticing it. Even more, they can tear apart a huge star like our Sun. And it's these giants that usually lie at the centers of galaxies. They're so heavy that their gravity holds countless stars, planets, and stardust around them. They can weigh millions or even billions of times more than the Sun. And now, you're back on the ground, at a rocket launch pad on Earth. All you can think about is holding your breath and jumping into the heart of that black pearl. But you don't have to hold your breath because you'll be in a spacesuit, and the oxygen is included free of charge. Besides, you're not likely to ever make it to the black hole. A trip that far with the technology we have now would take tens of thousands of years. Back to your garage where you stashed your hyper rocket, which will take you to the black hole in seconds. And you're next to two stars in a black hole. First thing you notice is that the black holes aren't black. Its gravitational force pulls in not only objects, but even light itself. This makes the hole invisible. You can only see a bright ring around it. That's called the event horizon. It consists of twisted light, hot dust, plasma, and pieces of asteroids that are also trapped there. So the event horizon is the first obstacle to overcome. Okay, you put on your jetpack, open your rocket's door, and jump towards the black hole. The force of gravity begins to pull you quickly toward it. The spacesuit protects you from the enormous temperatures and levels of radiation on the event horizon. Conventional protective gear would hardly help you, so you thank your dad for stashing this super powerful protective suit in your garage as well. You begin to feel like your body's stretching unpleasantly. The problem is that gravity increases with every inch closer to the center of the black hole, and it's much stronger at your head than at your feet. Your body starts to stretch like spaghetti. That's why it's called spaghettification. No suit can protect you from that, and there isn't a single spaceship that can withstand that kind of strain. Well, this was a short video. Okay, let's rewind to the moment before the jump. You realize that to get to the heart of the black hole and survive, you don't need improved equipment, but another black hole. And it's the size and weight of it that matters here. Theoretically, you can survive falling into a supermassive black hole. It's all about the width of the black hole's event horizon. When a hole is small, about the weight of our Sun, the event horizon is small too. And then its edge is remarkably close to the center of the abnormal gravitational force, which would make you spaghettified quickly and brutally. But if the event horizon is wide, it's farther from the center of the gravitational force. Then the difference of gravity pressing on your head and feet will be non-existent. So if you have enough air in your spacesuit, you can survive such a journey. So you must pick a supermassive black hole. Let's see. One at the center of the Milky Way? No, there's too much hot plasma and debris around it. You need a completely isolated black hole for a jump like this. Somewhere in dark space where it hasn't had time to gather the debris of neighboring worlds around it. You quickly open your space map and find such a black hole. One faster than light trip, and you've arrived. There it is! A huge dark nothing. There's only distorted light from distant stars and galaxies on its event horizon. To test your theory, you throw a mannequin into it. It approaches the black hole and then slows to a standstill. But it's just an illusion. The black hole is so heavy it can warp both space and time. So, to the observer, the dummy is frozen in the event horizon, but it has long since entered its heart. The dummy didn't get spaghettified like you did when you fell into a small black hole, so now you're confidently jumping after it. Remember that even if you feel fine, it's still a one-way trip. Once in the black hole's field of attraction, nothing can escape its embrace, no matter how powerful a rocket you have or how hard you flap your arm. You're now at the edge of the accretion disk. Every second here equals weeks or months on Earth. You're traveling through time. Our home planet may already have flying cars and skyscrapers several miles tall all over the place. But for you, it's only a couple of minutes. Whoa! All the light you see from the stars has turned red. That too is because of gravity. The light we see is waves, but the black hole stretches them out. The short wavelengths of blue become long and red. Great! You've passed the event horizon and are now heading into black nothingness. You look up and see a thin ray of light. The last thing you see, in fact. After that, there's just black void. No one knows what happens next. Some theories say black holes can be portals to another dimension, or to another place in the universe. By jumping into a black hole in our galaxy, you can jump hundreds of thousands of light years away from our home. In that case, you will experience your fall in reverse. First, you see a small but expanding beam of light. Then, red starlight returns to blue. And before you know it, you're back on the event horizon. And soon after, you're free of the black hole's pool. But scientists still can't confirm this theory. Okay, that's too grim. So just this time, we'll bring you back to Earth in the company of your friends. They praise you for your accomplishment of surviving the center of a black hole. Now you're the heart of the company, and no black hole can scare you. But even the biggest black hole in space isn't as scary as you might think. They have a lifespan. That radiation I mentioned takes energy from the black hole. If it doesn't have food around it, the hole starts to deflate like a balloon, and eventually there's nothing left. Another fear around black holes is that we can create one at home. Indeed, inside the Large Hadron Collider, scientists conduct experiments with small particles colliding at high speed. There are huge bursts of energy, and some scientists believe this energy is enough to create a microscopic black hole. It will begin to absorb its surroundings and grow. First, some small objects in the room where it was created. Then, the entire lab. The hole continues to grow and is already consuming our whole planet. It changes the balance of power in our solar system and absorbs the planets one by one. When those are finished, it's time for dessert, the sun. The light upper layers of plasma are stretched into long spaghetti and pulled toward the black hole. Then, layer by layer, our star collapses into the dark abyss. When the sun is half absorbed, the black hole shoots a beam of energy and light outwards and continues to consume the sun. In mere moments, there's nothing left of our solar system. That's how some people describe the end of the world. But even if we do manage to create a microscopic black hole, we'll be safe. It'll be too small to absorb big objects, and it will only feed on small atomic particles. Black holes emit energy as well as consume it, so our little one won't have time to grow. It'll lose more than it finds in a fraction of a second. So what you'll see is a momentary flash and then nothing. Although creating a stable and controlled black hole may even be useful, they emit enormous amounts of energy that we can use. A black hole the mass of Mount Everest could power all of humanity. Of course, black holes are still dangerous, but we can watch them and study our universe. If we stay far enough away, of course. So, you decide to put a padlock on that garage door. For now.
You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant! It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. 2 other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1,000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses. These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. Their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.
Have you ever seen the other side of the moon? Ah, I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the 2 sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959. all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the Moon, and it's the second largest impact crater in the Solar System. The collision also caused a powerful hot wave to spread across the Moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So stay tuned for new exciting research and discoveries. You're strapped in your seat in the vast open space with Earth behind you getting smaller and smaller. All around you are toggles and controls to keep the spacecraft intact. You and two other crew members are working hard at those controls. Out the window, you see some meteorites flying by and stars and planets out in the distance. You're about to be one of the first people to land on the Moon after years of research and testing. You have to consider all the steps perfectly. Otherwise, you could face many complications, like crashing into a flying asteroid, or even being left in the vacuum of space without any way of getting on track. Research shows that around 1/3 of all moon landings faced many problems. Launching towards the Moon requires a special rocket traveling at more than 25,000 miles per hour. And once in lunar orbit, the spacecraft can detach itself from the rocket and navigate its way to the surface of the Moon and land. Sounds simple, right? Well, figuring out the math to land was the reason landing a human on the Moon used to seem like a ridiculous idea. But scientists were able to pull it off by studying and observing the flight of helicopters. Unlike an airplane that needs velocity to take off, the large propellers on a helicopter give it a good push to fly around. It basically has to twirl with enough force to lift its own weight from the ground. With that in mind, we need to consider the gravitational force pulling everything down. On Earth, the force of gravity is 32 feet per second squared. On the Moon, it's only 5 feet per second squared. So we got landing on Earth figured out for the most part, but what about landing on a surface that barely assists you in that? There had to be 3 steps, doing all the research and math needed for calculating the proper conditions, using a test vehicle to practice in, and using a flight simulator to imitate the conditions of the Moon's atmosphere. Choppers weren't really good references for landing, since gravity is doing most of the work, and the spacecraft looks nothing like a helicopter. They needed to simulate a spaceship of only 5/6 the weight of it. Since the gravitational pull on the moon is weaker than on Earth, navigating it under these conditions is vital for when the real thing comes. The scientists of NASA decided to get a crane hangar to lift the spacecraft with cables while simulating the flight and landing. Kind of like stunt actors in a movie with cables attached to them for action fight scenes. But it still wasn't enough to determine if you could actually land properly on the moon without the safety cables to help you. They needed proper freedom. So it was back to the drawing board. They were about to throw in the towel until they came up with a brilliant idea to simulate the landing conditions on the moon by installing a sort of detachable jet fan into the bottom of the spacecraft to keep consistent thrust upwards. By doing this, they were able to create a scenario where the craft would be 5/6 of its weight on Earth and without the safety cables to hold it. But after many trials and errors, the only way to see if landing on the moon was possible was by actually doing it. So, being so far away from Earth, you and your team see the moon out your window. It's a lot bigger than it looks from Earth. Its surface fills up the entire window. But landing won't be a piece of cake. The spaceship has to orbit around the moon to determine the best time to land. And don't worry, that's why you have a team for that. It can take more than 24 hours to know when and where the perfect place to land is after performing various tests and measurements. And once you get the best calculations, the actual spaceship detaches from the orbiting one and makes its way downwards. This is where the helicopter physics come into play. A helicopter needs to tilt at least 5 degrees to move forward after ascending from the ground. Same for going backwards. But that's because we have gravity to assist it. Up above the moon, soaring through the vacuum of space, the ship would need to tilt at least 30 to 40 degrees to move forward. As soon as the ship reached a nice spot for landing, it would go back to 90 degrees and slowly land on the surface. As you get closer, you can see the moon's surface just a few feet away. This is the tricky part, but it's a success. The team back on Earth couldn't be happier. The crew members are also thrilled about what you've achieved. You put on your spacesuit and gear and climb down the ladder. You leave your first footprint on the moon and look out at the distance ahead of you. The Earth is just a little blue dot far away. You're able to bounce around in the near-zero gravity. Now, that's what I call moonwalking. After spending much time on the moon, it's time to head back. Neil Armstrong, the first man to step on the moon, spent only about 2.5 hours on its surface before returning. But, oh no, you forgot the keys inside the ship and now you're stranded. Nah, just kidding. Although it would have made a good plot twist. You get back and launch the spacecraft back into orbit to reunite with the other ship above you. And once you've reattached, you exit the moon's orbit and head back to Earth. By sending humans to the moon consistently, the next big step can be achieved by landing on Mars. The famous exploration rover Curiosity traveled around the surface of Mars and gathered information needed for humans to land there. And NASA is aiming to have the first humans up there after 2030. The journey will be hundreds of times harder than the one towards the moon, but many scientific questions will be answered once it happens. Humans may be able to gather some of the natural resources there and even build outposts and colonies. There are endless possibilities as well as challenges. The journey from the Earth to the Moon is around 250,000 miles. Mars is around 35 million miles away. There could be a possibility of a new human outpost stationed on Mars, building a new society of scientists and engineers to make the most out of the conditions. It would be completely self-sufficient, providing proper ways for farming and agriculture. And by having humans on Mars for so long, scientists can properly understand the planet. But to understand how the human body responds to deep space environment, we'd have to have a lot of practice before getting that ticket to Mars. The closest experience of having a colony in the middle of nowhere is the Amundsen Scott Station on the South Pole. It's designed to withstand all the harsh conditions of the freezing dry cold. Being at the bottom of the world can be pretty stressful without proper practice. The journey may not be as far as Mars or the Moon, but being on the South Pole is like arriving on a whole new planet. The station itself is equipped to provide the proper conditions everyone needs to be comfortable. Besides the strong heating system, the station has a recreational room for sports and music, a library, a lounge, and even a greenhouse to grow all the right veggies and fruits. In fact, the greenhouse is the only way you'd get to feel like you're in a rainforest. And even before applying there, you'd have to get screened to see if you can handle the isolation for months. Not that you'd be completely alone, but still away from civilization. Antarctica's whole population consists of scientists and engineers, and you need to be examined by a doctor to determine if you're physically fit to stay there. The station is built there for scientists to study space and things related to geology. Being in the biggest desert in the world can take its toll on you. When leaving the station, you have to wear at least 3 layers of gloves and extremely thick sweaters and jackets to withstand the cold. They even compared stepping on the South Pole to walking on the Moon.
Time runs like a river. It has direction, always advancing. It has a certain duration, periods between events you can measure. Time feels real, always there, unstoppable, moving forward. But what if I told you that time might not exist? Some physicists and philosophers claim that there might be no such concept as time, and we should take this possibility of the non-existence of time seriously. You see, recently physics has been in crisis. For the past century or so, 2 extremely successful physical theories have been used to explain the universe. Those are the theory of general relativity and quantum mechanics. Quantum mechanics describes how things work in the super tiny world of particles and their interactions. As for general relativity, it provides an outlook on the bigger picture, for example, gravity or how objects move in space. And even though both of these theories seem to be working really well, they are believed to conflict with one another. That's why some scientists think that they need to be replaced with a new, more general theory, like quantum gravity. This idea might be able to explain how gravity works at the miniature scale of particles. Apparently, it's incredibly difficult to produce the theory of quantum gravity, but it might be possible to do it with the help of string theory. It replaces particles with strings, vibrating in 11 dimensions. But there's one problem. Even though string theories do provide several models describing the universe, they don't make any clear predictions that can be tested by experiments to understand which model is the correct one. There's one more idea known as loop quantum gravity. According to it, the fabric of space and time is made of super tiny chunks, loops. But the most remarkable aspect of this theory is that it completely eliminates the concept of time. Now suppose this idea turns out to be correct. Will it mean that time doesn't exist? Well, the answer is kinda complicated. Everything depends on what the word exist means. A philosophy professor from Cambridge University claims that the 3 basic properties of time, a present moment that is special, the flow of time, and its direction, come from our mental states and not from the physical world. So we sense this arrow of time because our minds add a certain subjective ingredient to reality. At the same time, Einstein's theory of relativity supports the idea of the block universe, a 4-dimensional space-time structure where time is like space. It has its own coordinates in space-time. Time is tenseless there. Thus, the future and past are as real as the present. Does it mean we're being fooled by our human perspectives? Is the feeling that time passes and has a certain direction false? Well, we can imagine our world as a 3-dimensional place where stuff happens gradually over time. Or it might be a 4-dimensional space where nothing actually happens because nothing changes. It's all here at the same time, past, present, and future. The main idea of relativity is that there's no absolute space and no absolute time. Everything is relative. Trying to think about time in the context of the universe, you realize that you need to isolate part of it and call it, let's say, your watch. And time is basically the relationship between some parts of the universe and that thing you called your watch. Another scientist says that time is just a collection of snapshots describing our reality while continuously changing one into another. Here, you hit play. Here, you're blinking while watching this video. And here, you're taking a sip of your coffee. Without these changes, there wouldn't be any notion of time. The changes are real, but time is not. Our brain sees these changes and constructs a sense of time, believing that it's flowing. What do you think? Is time just a social construct, or does it really exist?
Oh boy, you can't stop seeing images of funny pandas on your final exam sheet. All those late-night YouTube videos hit you hard, huh? You scribble down some words, hoping that something makes sense. You look at your watch and realize you've got only 10 minutes to finish. Panic mode is officially on, but no one knows your watch has a pinch of magic in it. You click the stop button on your watch and relax. Don't worry, no one will turn to dust and half the universe won't disappear. You simply freeze everything in time except yourself. With this ability, you can stop the time for 1 minute a day. So after freezing time, you get to one of your classmates, take a picture of the assignment, and head back to your seat. You unfreeze the time and write down the proper answer. Phew! At least you can guarantee a passing grade. I'm Steve from Legal. Want to make sure you know that Brightside does not condone cheating on a test. Okay, carry on. You walk out of the classroom with a large smile on your face. You check your watch and it says you spent 10 seconds of time freezing. 50 seconds left. After that exam, you go and grab something to eat. You're at the traffic light waiting to cross the street. Hey, there's a girl talking on the phone and a car is speeding up to her. Everyone sees it, but nobody can do anything, and the car is only a few feet away from her. You click the stop button and everything freezes again. You run up to that girl and move her as fast as you can. Then you run back to where you were standing and click the button again to unfreeze time. Everyone is confused, but at least the girl's safe now. The whole mission took you another 10 seconds. 40 seconds left. You enter the coffee shop to grab a quick bite. As soon as you get your coffee, you turn around and lose balance. Your drink is falling down and about to spill. You click the button instinctively, and the drink is now literally hanging in the air. You collect all the droplets and put them back in the cup and click the button again. You just saved yourself $5 and a dry cleaner's trip. You realize you spent 15 seconds saving a drink. 25 seconds left for today. As you're walking to the bin to throw away the cup, someone bumps into you. The buckle unfastens and the watch smashes onto the ground. You pick it up and see a scratch on the display, plus some parts came off. You gather the parts, trying to fix it. As you're doing so, you see a fly next to you and shoo it off. Strangely, it doesn't even flinch. You look around and see everyone frozen in time. The person who bumped into you is still in mid-motion. The pigeons eating breadcrumbs are frozen too. So are the cars and people. Since the watch got damaged, it reversed the power. Everything is on pause, and now you've only got 25 seconds of regular time. If you waste it all, you'll be frozen in time forever. At first, you try your best to fix it, but don't know what to do. You take out your phone to browse some tutorial on how to fix a watch, but it won't load. You keep refreshing, but nothing happens. The internet can only work in real time, and 25 seconds aren't enough for anything. There's only one place now where you can learn how to fix watches in this situation: a library. You'll have to read about it and learn from scratch. You rush to the closest library, which is at the campus. Turns out there are only a few books on how to repair watches, but they have zero info you need. You find a bike and pedal all the way across to the public library. It took you 4 hours to get there. Once you've arrived, you look at endless bookshelves. You could easily switch back to real time and ask the librarian where to find what you need, but then it might take longer than you have left. There are way more books than you expected. You pedal back home and grab some stuff to sleep and eat. It's going to be a long day. When you're back, you grab a few large books that seem to have the answer. No social media can distract you, since the internet doesn't even work. The time passed, and you finally finished 2 large mechanics volumes. But there's just one problem. You can't find volume 3. Your only chance is to turn on time to do a quick internet search on where it is. You can't download an ebook, since it will take much time and it's impossible to print in frozen time. You click the button and time resumes. Everyone looks confused about a mattress and food leftovers all over the library floor. But you do a quick internet search and find out that you can order the book now and receive it the next day. Yeah, right. It turns out the closest book is in a library on the West Coast. Bad news, you're in New York. And what makes it worse is that the only source was updated years ago. The book may not even be there. You freeze time again. It took you 10 seconds to get all the needed information. You have no choice but to go on a road trip that will take around half a year by bike. No other vehicle is available to you. You find the best bike and gear, pack up some provisions, and leave the town. You travel through the mountains, swamps, and dry lands. You bike through frozen waterfalls and cut across heavy storms, frozen in time. You find indoor places to sleep, since time is frozen during the day. But you actually took your time getting there and lengthened your trip to see all the sights around the country. You spent a week at the Grand Canyon and a month in Yellowstone. You went up to bears and wolves so you can actually see the details of their muzzles. You even decided to pedal all the way to Mexico to check out the amazing scenes and landscapes around. You visited all the cities and towns without worrying about money or a proper place to stay. Steve from Legal again. Brightside does not condone using stuff without paying for it. Remember, this is a fantasy trip. Okay, continue. After covering all of Mexico, you continue all the way down through Central America, where you got to witness even more amazing sights and landmarks. Hey, you've already gone this far, why not continue pedaling down to South America? You can even visit your friend in Argentina. I mean, he wouldn't know you're there, but it would be nice to pay him a little visit. After sunbathing in Brazil and mountain climbing in Bolivia, you end up at the southernmost point in South America and admire the journey you took. Right across the ocean is Antarctica. It's impossible to get a boat and sail there, so you decide it's time to get back to business. According to your calculations, it took you about 4 years to complete this journey. But you finally reach the library. You take out some water to drink, but accidentally drop the watch on the ground and resume time. Everyone is in motion. Cars are honking their horns, dogs are barking, people are screaming and shouting at each other. You haven't heard a human voice in such a long time. Some people are staring at you. You're overwhelmed by all the energy around you, but suddenly wake up from it. You fumble trying to find the watch. Here it is. You stop the time. Only 3 seconds left. You spend what seems to be another month in that large library trying to find the 3rd volume. You've got no more time to do another internet search with those 3 seconds. After you finally found it, you spend 2 more months figuring out how to fix your watch. When you're done, all you have to do is click the button to bring everything back to normal. But you decide to pedal all the way back home. You clean up all the mess in the library and go back to the coffee shop where it all started. You even return the bike you borrowed. This is it. 3 seconds to see if all that work was for nothing. You click the button and watch time move on. You look at your watch. 3, 2, 1. Whew! Everything is back to normal. You go back home and lock up that watch in your drawer, never to look at it again. Until next time.
15,000 years after the construction of the first space colony, planet Kepler 452b, 1,400 light years from old Earth. Hello, first-year students. We're glad to welcome you to the Intergalactic University. Endless space is now home for us humans, but thousands of years ago, we used to live on just one planet we now call Old Earth. Yes, I understand it's difficult to believe. Today, it's one huge nature reserve. Mammoths and stegosaurs walk on its surface, and pterodactyls fly in its skies. It turned out to be easier to recreate animals that roamed it millions of years ago than to understand how our ancestors lived. The Great Cataclysm made them abandon the planet in a hurry, leaving much of its legacy behind. And now, we're studying it anew. But our excavations leave more questions than answers. Skyscrapers, highways, shopping centers, coffee shops, everything is buried under sand and soil. Rust has eaten away the metal, and time turns concrete into dust. Even the Hoover Dam and the Three Gorges Dam in China have crumbled. The colossal structures turned into heaps of stones. The remaining buildings have become overgrown with plants and turned into a home for millions of living creatures. But there's good news as well. Faces carved into Mount Rushmore are still visible. The mountain is granite, and this rock is one of the hardest on old Earth. For over 15,000 years, the faces of U.S. presidents have deteriorated by only 2 inches. The monument will stand for millions of years. And the latest expedition to the Sahara Desert managed to dig out the Great Pyramid from the sand. Now any tourist can buy a ticket and look at that wonder, which even Earthlings considered very old. Surprisingly, ruins and crumbling walls of medieval castles in Europe have survived. They're built of massive stones and without metal fittings, which expand and destroy the stone when rusting. Our ancestors left behind a huge amount of garbage. Empty bottles, plastic packaging, wrappers. All this helps scientists to recreate the consumption patterns of people of the past. Thanks to this, we know for sure that in the 2000s, almost 8 billion people ate mostly chips, chocolate bars, and pizza. And they rarely drank ordinary water. They loved coffee, though. 60% of Earthlings lived on the internet for 7 hours a day. 2 billion websites worked 24/7. At first, information was stored on hard disks, flash drives, and compact disks. But this kind of storage went obsolete after a couple of years. The cloud took their place. It was an online storage with servers connected to the global network. They recorded the entire life of Earth's civilization and were stored in data centers. In space, the Earth's internet didn't work well. Apparently, huge distances and lack of technical knowledge did their job. Imagine that a Pluto resident wants to know the difference between margarita and calzone pizzas. They click the link and wait for a couple of hours for it to open. If the dough's already in the oven, no good. Each colony organized its own internet by sending satellites to orbit their planets. It took time to connect thousands of colonies into the intergalactic web we now know as Uninet. When the cataclysm struck, people had to escape, leaving their planet to its fate. Electricity went out, no one maintained the servers and data centers, and lots of info about their civilization was lost. We've scanned miles deep into the Earth and found many interesting artifacts. Students, I invite you to look at this amazing thing. The Earthlings called it a camera. People took pictures of their food, morning runs, and new shoes on it. One thing our scientists couldn't comprehend, though, is that ancient people used to communicate with its help too. One of the main mysteries of the past are the dishes of different sizes. Archaeologists find them in almost every home. They bear these names: Buddy, Cosmo, Rex, Princess. We know these were the things from which dogs and cats ate, but we don't know why people pampered these animals so much. For example, archaeologists recently unearthed a beauty salon for poodles in San Francisco. I also love my dragon from the jungles of Gliese 832c, but I don't perm its fur and manicure its claws. And this is my favorite artifact, a book. There's nothing more valuable in the universe. There's only one sample in my antiques collection. It's a cooking recipes anthology. I paid a fortune for it. The ruins of museums are treasures for archaeologists and all the new humanity. These buildings collapsed a long time ago and now look like ordinary hills, overgrown with trees and grass. Museums are like pearls in the ocean. They lie at the bottom and wait to be fished from their shells. And sometimes, archaeologists manage that. Books, paintings, documents, and clothes have mostly turned to dust. But we can enjoy the statues that were carved out of marble by masters of ancient Greece and Rome. On the walls of caves around the world, there are drawings of animals and handprints of the first people. They didn't know how to read, drive a car, or fly a spaceship, but their paintings have survived. It's incredible. Over thousands of years, time has eaten up huge dams, cities with skyscrapers and bridges, and the palm of an ancient human still adorns the cold and rough wall of a cave. Space archaeology is becoming more and more popular. Thousands of tons of space debris fly around old Earth. The real sensation is the discovery of the Voyager 1 probe. Earthlings sent it into space at the very beginning of their development. I see your condescending smiles. Today, such a device can be assembled by any first-year student from spare parts in their parents' garage. But, dear students, let's not laugh at our ancestors. They tried their best. Voyager isn't a simple satellite. The device can be compared to a message in a bottle thrown into the sea. And the cosmic sea is millions of times larger than the Pacific Ocean of old Earth. Engineers of the past left a time capsule with a message in the probe. It contains photographs of people and the nature of the planet, as well as scientific information about the Earth. 90 minutes of recorded music are of particular interest. This is a real gift from our ancestors to us, to the people of space. Radio signals that humankind sent into space have also survived. We've tracked them. Radio broadcasts, phone conversations, even music charts continue their journey through space. Millions of years later, they'll weaken and leave behind only an electromagnetic echo. In 2020, there were 1.4 billion cars on old Earth. Unbelievable! But they moved along asphalted roads on rubber tires, not in the air. When humans flew into space, they left their vehicles on the planet. Within just a couple hundred years, the cars went completely bust and turned into piles of metal, plastic, and rubber. One that survived for millennia was the Lunar roving vehicle. There's no air, no water, and no earthquakes on the moon. Anything that comes here becomes kind of suspended in time, and that's what happened to the rover. Archaeologists have found a lot of other whole and crashed spacecraft on the moon. These devices are priceless artifacts in the Museum of Primitive Earth Technology. In the Svalbard archipelago in the Arctic Ocean, scientists have unearthed the Global Seed Vault. Earthlings built it in 2008. It became a real sensation. The huge silo contained 4.5 million samples of 500 seeds each. Billions of seeds have helped provide agriculture for the colonies. Now you can eat popcorn and hamburgers with real bread rolls thanks to those. For thousands of years, the seeds were kept without human attention. This isn't a miracle, but an accurate scientific calculation. The vault is built underground at a depth of 390 feet. There are no earthquakes or floods there, and the permafrost provided the optimum temperature for the seeds to survive. Most metals are mined from ore. These ores don't contain pure metals, but only their chemical compounds. To get pure iron, the ore must be smelted first. But there's a problem. Metals from ore oxidize on contact with water or oxygen. Simply put, they rust. This is how metal returns to its natural ore state. That's why nails, metal fences, bridges, and houses rust and collapse. But this doesn't happen with gold, silver, and platinum. Things made from these metals are eternal and will never lose their shape. Of course, if you don't start hitting the rings and pennants with a hammer. During excavations, archaeologists find thousands of jewelry items. Earthlings love to wear them on their bodies. Crowns, luxurious necklaces, wedding rings. All this jewelry is now history, kept in galactic museums. Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila! We have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A, with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974. And we'd have to wait another millennium to get a response from them.
Another problem with radio waves is that they don't look like a constant glow on the planet, but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify, but its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after 2 neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shockwave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our Sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planets. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updating. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
You're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down, since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott's South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets. You take off from Earth and park your spacecraft somewhere near the moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Thea, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon, it gets so high that it triggers a nuclear chain reaction. Another second, and bam! There's an explosion so powerful that the shockwaves travel far into dark space, and the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Thea. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Thea was kind of a ball Jupiter and Venus played with. Venus was pulling Thea in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Thea move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Thea is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Thea is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Thea itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Thea touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Thea happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Thea and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day, they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Thea. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Thea that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Thea, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Thea are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Thea. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Thea might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Thea did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Thea remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light-years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there. When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, It knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then, the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and